welcomes you for watching this video. Please do not forget to like, comment and subscribe our Registered Values Club for getting all new professional updates on valuation topics. In this video, we will discuss about the statistical methods for land and building valuation, especially from a IBBI examination point of view. So this comprehensive guide will cover the essential statistical methods for land and building values who are preparing for IBBI examination, from basic data classification to advanced time series analysis and index numbers. This document will provide you detailed explanation, mathematical formulas, practical examples, and real-world applications specifically for the property valuation. So each section includes numerical problems with step-by-step solution to help solidify understanding of statistical concepts critical for accurate property assessment and valuation. In this video, we will discuss basically about how the statistical methods are used for land and building valuation, and we will try to do the various types of practical examples to make the things clear about this, about the various statistical methods. So we will we starting with the basic things, how the statistics help in property valuation. So in this slide will guide you about the statistics in property valuation. You know, the statistics plays a crucial roles in the field of land and building valuation, providing valuers with quantitative tools to analyze property data, identify trends, and establish reliable valuations and make evidence-based decisions. So this will not only helpful for the working professionals, it will also help for those who are preparing for insolvency and bankruptcy board of India examination for land and building values. So a solid understanding of statistical method is very essential for a successful value. So how these statistics methods are applied in property valuation, we will discuss about these things such as collecting of data, organizing of data, analyzing of data, and of course interpreting numerical data related to property characteristics, market conditions, and economic factors. These methods help valuers move beyond subjective assessment to establish objective, defensible valuations based on empirical evidence. So, statistical analysis enables values to determine a fair market value based on comparable sale data, identify significant factors affecting property values, quantify the relationship between property characteristics and value, forecast future value trends, measure and account for market volatility and risk, establish confidence intervals for valuation estimates, and validate valuation models through hypothesis testing. So throughout this presentation, we will explore various statistical concepts and techniques which are specifically applied for the property valuation. Each section will provide theoretical foundations, relevant formulas, practical examples, and applications specific to the field of land and building valuation. The material is structured to help candidates develop both conceptual understanding and practical skills, which are also essential for IBBI examination and professional practice. So as we progress through the increasingly complex statistical method, remember that these techniques are not merely academic exercises but practical tools to enhance the accuracy, reliability, and defensibility of property valuations. So, whether analyzing comparable sale data, developing regression models to quantify value factors, or forecasting future property value trends, statistics provides methodological foundation for modern valuation practice. First of all, as far as IBBI syllabus is concerned, and of course, as a professional valuer, you must understand that different types of data, how the class data is classified, how it is processed in property valuation. First of all, you should understand the various types of data. There are basically two types of data. One is qualitative data and other one is quantitative data. So the data is of two types. One is qualitative data and other one is quantitative data. Qualitative data is that which give the descriptive information only that cannot be measured basically. That is called qualitative data that cannot be measured numerically, but it can only be categorized, such as we can say that property zoning, whether the property is residential, commercial, industrial, or construction quality, you can say poor quality, average quality, good quality, excellent quality, or such as neighborhood qualifications. So the data which cannot be made numerically, that is called qualitative data, that gives the quality of certain factor. So the second one is quantitative data. That data which is expressed numerically, and that numerical information can be compared mathematically. So the numerical information that can be measured and compared mathematically is called quantitative data. For example, property size in square feet, sale price, rental income, building age, or number of rooms in a building. So there are different classification methods of the data. First, in especially in case of property valuation. So for effective statistical analysis, property data must be organized into appropriate categories, such as we categorize the data with respect to geographical classification, such as organizing property by location, city, neighborhood, postal code, etc. And then arranging the data by time period, such as quarterly sale, annual sale, annual appreciation rates, etc. Then qualitative qualification, grouping properties by non-numeric attributes such as property type, architectural style, etc. And quantitative classification, such as organizing numeric data into classes or interval, such as price ranges, size, categories, etc. Now we will discuss about the data processing, how the data which you have collected and categorized, how it is processed. So stages in data processing is first thing is data collection. So gathering relevant property information from reliable sources such as property registrars, office, market transactions and field survey. And then after collecting this data, we will try to identify and correct the errors in the data, handling missing values, and removing outliers that could skew analysis. And third one step is data organization. So first, when you have collected the data, you have removed the errors and other things from the data means you have cleaned the data, then you have to organize it. So structure data into format suitable for analysis, often using spreadsheets or specialized valuation softwares. Then after and organizing it, you have to analyze the data by applying statistical techniques to extract meaningful insights and patterns from the organized data. And from the data analysis, you will interpret the conclusions from the analysis to inform the valuation decisions and your recommendations. So, as far as IBBI examination purpose is concerned, candidates should be proficient in recognizing different data types encountered in property valuation, understanding appropriate classification methods, and demonstrating knowledge of proper data processing procedures. The foundation is essential for applying more advanced statistical techniques covered in the subsequent sections of this presentation. So, next is how you have to represent the data. First type is graphical representation of data. So there are different methods of graphical. So graphical representation, we can represent the data in different types. First type is bar chart. So bar charts are generally used to compare property values across different categories such as neighborhoods, property types, or time periods. Each bar represents a category and its height corresponds to the value. So how it is applied in valuation? So you, for comparing average property prices across different neighborhoods, or showing distribution of properties by size category, you can use bar graph. And another method of representing is absolute line graph. So with the help of line, and second uh, way of representing the data is through line graphs. So it displays changes in the property values or other metrics over time, showing trends, cycles, and patterns in the data. So it can be used for tracking property prices or price indices over time, monitoring rental yield changes, or analyzing vacancy rates or trends, etc. And the third method of representing the data is through pie charts. So it shows the composition of a whole by dividing it into sectors, and each sector represents a proportion of the total. So how it can be used in valuation? It can be used for illustrating the distribution of property types in a portfolio, land use allocation in a development, or sources of property income, etc. Then there are certain advanced graphical techniques which you can use in data representation. First one is scatter plots. So plot individual property as points on a graph with two variables. For example, a graph between size and price, which help to identify relationship and the outliers. For example, you plot property size against sale price to identify the relationship between these variables and detect the properties that may be overvalued or over undervalued relative to the trend. And then another method is box plots. So what box plots do, they display the distribution of property values showing median, quartiles, and outliers, providing the insights into data spread and skewness. So comparing the distribution of commercial property values across different business districts, highlighting median values and price variability each area is an example of how you can plot the data with the help of box plots. So it is very important to create effective graphs for property valuation. So how it can help you in property valuation? So to ensure graphical representation of informative and accurate, select the appropriate graph type based upon the data and the story you want to tell. So label the axis clearly with the appropriate units, for example, rupees per square feet, acre, or years, etc. Then use consistent scales when comparing with the multiple data sets and include a clear title and legend that explains what the graph represents. Consider color coding to enhance clarity. For example, using different property types, you can use different colors. Then annotate significant data points or trends that require attention. So, effective graphical representation transforms complex property data into visual insights that can inform valuation decisions, support appraisal reports, and communicate findings to the clients and stakeholders. As far as the IBBI examination is concerned, candidates should be able to create appropriate graphs for different types of property data and interpret what these visualization reveals about the underlying market dynamics. Next topic is frequency distribution. So we will be using this frequency distribution in context with the property valuation. So basically what frequency distribution do? Frequency distribution provide a structured way to organize and summarize large set of property data, making patterns and characteristics more apparent for land and building valuers. Frequency distribution help identify market segments, price bands, and distribution of property characteristics within a data set. So, different types of frequency distributions are used in property valuation. First type is ungrouped frequency distributions. So, what we do in this type of frequency distribution, we list each unique value along with its frequency of occurrence. So it is suitable for discrete data with a limited number of values. For example, you distribute properties by number of bedrooms. For example, one bedroom, 15 properties, two bedroom, 42 properties, three bedroom, 38 properties. So in this way, you can do ungrouped frequency distribution. And second type of frequency distribution is grouped frequency distributions. So what we do in this case, we organize continuous data into interval or classes counting the frequency of observation in each class. For example, distribution of property prices in rupees 10 lakh intervals, 20 to 30 lakh, 12 property, 30 to 40 lakh, 25 properties, etc. And then third type of frequency distribution is relative frequency distribution. So what we do in the relative frequency distribution, we express frequencies as a proportions or percentage of the total observation. For example, percentage of properties in each size category under 1000 square feet 15%, under 1000 to 1500 square feet 40%, etc. And another method of frequency distribution is cumulative frequency distributions. So what it shows? It shows the accumulated frequency of observation at or below each class limit. For example, number of properties valued at or below certain price points, for example, say less than equals to 30 lakh or 35 properties, less than equals to 40 lakh, 60 properties, etc. So how you can how this creating a group frequency distribution help you in valuation of real estate. So it helps to create group frequency distribution to determine the range. You can find out maximum value, minimum value, etc. from the frequency distribution. Then you can choose appropriate number of classes, typically 5 to 15 depending upon the sample size. Then you can calculate the class width. Class width means how you can calculate the class width. You divide the range with the number of classes, round up to the for the convenience, and establish for each interval class limit and count the frequency of observations falling in each class. So how this is done, we will be doing it with an example. Let us suppose you have 50 residential properties with the following sale prices in rupees lakh. So these are this this property was sold for 32, this was 45 lakhs, 48 lakhs. So this is the data you have collected for 50 residential property. First of all, what you will do, you will try to arrange the data in the ascending order. So see here, the maximum price of the property is 63 lakh and the minimum price is 23.7 lakh. So range is maximum minus minimum. So range is 36 lakh. Means property values are varying from rupees 27 lakh to 63 lakh. Means there is a variation of 36 lakh in, over these 50 properties. So let us suppose we use a number of classes, 6 number of classes. So we divide this 36 lakh range in 6 classes means the class width will be 6 lakh. So how we preparing a graph? We prepare a bar graph by using the data above. See here, first in properties, we are having 8 properties whose value varies between 27 to 33. Then we have 12 properties whose values varies from 33 to 39 lakh. Then we have 6 properties having size array of value varying from having value approximately we have 10 properties having values varying from 39 to 45 lakh, and then we are having 8 properties whose values varies from 45 to 51 lakh. Then we have approximately 7 properties whose values varies from 57 to 57 lakh, and then we have approximately 5 properties whose values varies from 57 to 63 lakh. So in this case, where we divide and the range into different sectors, and see here, this is the width of each class, 6 27 to 33, and see here number of classes are 1 2 3 4 5 and 6, and in each class property varies by 6 lakh. So how we apply this in property valuation? So frequency distribution, how it helps a value? So it identify the most common property price ranges in the market. It determines the typical property sizes, ages, and other quantifiable characteristics. It recognizes price clusters that may indicate market segments. It establishes appropriate comparable property sets based on the distribution patterns and detect outliers that may require special consideration or exclusion from the analysis. So, as far as the IBBI examination is concerned, candidates should be proficient in creating and interpreting frequency distribution for various property characteristics, understanding how these distributions inform valuation analysis, and recognizing the implication of different distribution patterns for market segments and property value estimation. Next topic is central tendency and how the measure of standard tendency help in property evaluations. So first of all, you must understand what are the measures which are essential as far as central tendency is concerned. So basically, measure of central tendency are statistical values that provide represent center or typical value of a data set. In property evaluation, these measures help to identify representative property values and provide reference points for comparison. Understanding and appropriately applying these measures is essential for accurate property valuation analysis. So there are three things which as a valuer you must understand is one thing is arithmetic mean, second is median and third is mode. So mode, mean and median are the basic things for the values. So what is arithmetic mean? Arithmetic means is the sum of all values divided by the number of observations. First, first measure of central tendency is arithmetic mean. So, how this arithmetic mean is calculated? First of all, we take the sum of all the values and then we divide it with the number of observations. So, this is the formula for calculating the mean. Mean is equals to, we represent this mean with x bar. This is sum of all the observations, the values of the observation from I to n divided by n, which is number of observations. So where xi represents each value and n is the total number of observations. Second thing you have to find out is median. So median is basically when you have a data set and the middle value of that data set is called median. So for calculating median, first thing what you have to do, you have to arrange the values in the ascending or in the descending order. So if the data set is having odd number of observations, then it will be the middle value, and if the data set is having even number of observations, then you have to take the average of the two middle values. And third thing is mod. So mod, what is mod? Mod is basically the most frequently occurring value in the data set. So a data set may have one mod that is called unimodal. It may have two modes, which is called bimodal, or multi-modes, which is called multimodal. So this is the three things basically which are generally used: arithmetic mean, or mean, mode, and median. And another thing which is also important is weighted mean. So weighted mean is basically calculated if in case of a property valuation. What happens is that not all properties contribute equally to the analysis. So the weighted mean accounts for the relative importance of each observation. So how this weighted mean is calculated? It is sum of WIXI divided by sum of WI. So where WI is weight assigned to each value XI. So now we will take an example that will make the things clear that how you have can calculate the weighted mean and other things. See, you have calculated the data of a seven recently sold comparable property in the neighborhood of the property of which you have to do the evaluation. So these are seven properties A, B, C, D, E, F, and G. So sale price of A is 58 lakh. Its built-up area is 1,200, and the rate per square feet is 4,833. Similarly, you have different sale price for different areas of the property, and we calculate the price per square feet in rupees. So if you have to calculate means you have to take the sum of all the observations and divide it with the number of observations are 7. So if you take the sum 58 plus 62 plus 54 plus 65 plus 60 plus 54 plus 60 plus divided by 7. So it will be 60.14 lakh. And median, for median you arrange these values in the ascending order 54, 54, 58, 60, 69, 65, 68. So see here, the number of observations or number of values are 1, 2, 3, 4, 5, 6, and 7. So you have to take the middle value. So this 60 lakh, it is a middle value. That will give you median. And mod is the most occurring value. So see here, in this case 54 is which is occurring two times. So the 54 appears twice, so the mod is 54. And if you have to calculate weighted means, so weighing each property by its built up area. So see here, this is amount is 58 lakh multiplied by 1200 plus 62 lakh multiplied by 1350. Similarly, you multiply it each sale price with the plinth area and divide it with the sum of all the areas. And if you calculate this, this will come out to be 60.58 lakh. So see here, which method you will be using for calculating or assuming the value, which central tendency will be appropriate for a particular case. So you will be using mean when data is normally distributed with extreme outliers. You need to account for all the values in the data set and performing further statistical calculation. And you will be using median when the data contains outliers that would skew the mean. So basically what happens, let us suppose you have values in the range of 20 lakh to 30 lakh, but one of the value which you have collected from the data is, let us suppose, 95 lakhs. So what it will do, it will increase the mean of the all the values when you will take the mean. So instead of using mean here in this case, when there is some values are much higher so than the other values, so in that case we will be using medians. So what it will do, this will increase the mean of the data set, and thereby it will skew the mean. So the distribution is significantly skewed. So this is when we use median. So reporting typical property values, you will be using median. So mod, when you will be using mod, identifying the most common characteristic and working with the categorical data, for example, most common property type, and determining the most popular price point, you will be using mod. So application, how this mean, mod and median is used in the property valuation. So measure of the central tendency are used in the valuation for establishing baseline values for comparable properties, determining the typical property characteristics in a market, analyzing trends in a property values over time, comparing property values across different neighborhoods or property types, and supporting valuation conclusion with statistical evidences. So far as the IBBI examination is concerned, candidates should understand how to calculate each measure, know when to apply each one based upon data characteristics, and interpret what the measures reveal about the properties, market, and value distributions. So next is elementary theory of probability in property valuation. So now we'll be discussing basics of the probability and how it is used in the theory of probability is used in the property valuation. So probability theory provides a framework for quantifying uncertainty in property valuation, enabling values to assess the risk and make evidence-based predictions. So the IBBI examination may test candidates' understanding of the basic probability concepts and their application to the property valuation scenario. Mastery of these concepts allow values to express confidence levels in their valuations and analyze potential outcome in uncertain market conditions. So there are three types of probability. One is classical probability, second one is relative frequency probability, and third one is subjective probability. So what is classical probability, which is generally used? So based on equally likely outcomes, it is calculated based upon equally likely outcomes. It is calculated as PA probability. It is equals to number of favorable outcomes divided by total number of possible outcomes. For example, the probability of a property selling within 3 months. If historically 7 out of the 10 similar properties will sold within this time frame, it will be 7 divided by 10. 7 divided by 10. So 7 is number of favorable outcomes and 10 is maximum number of possible outcomes. So the value is probability value is 0.7 or we can say 70%. So and remember probability is always less than 1. Then second one is relative frequency probability. So based on historical occurrences, it is calculated as number of time events A occurred divided by total number of observations. For example, if 45 out of 200 commercial properties in a district were vacated within a year, then the probability of commercial property becoming weightage is 45 divided by 200 means 0.225 or 22.55 to 22.5%. So this is relative frequency. Third one is subjective probability. Oh, sorry, relative frequency probability. Third one is subjective probability. Based on this is based on expert judgment when historical data is limited. For instance, and an experienced valuer might assign a 60% probability to a proposed infrastructure project being completed on schedule based on government track record and budget allocations. So these are the three types of probability which you must as a valuer know. Next is fundamental probability rules for a property analysis. First rule is addition rule, means P A or B equals to P A plus P B minus P A and B. For mutually exclusive events, P A or B is equals to P A plus P B. So is to make the things understandable, we will take an example that will make the things clear. If the probability of a property price appreciation is 0.65 and the probability of increased rental yield is 0.45 with the zero point 0.3 probability of both the occurrence, means property price appreciation probability is 0.65 and rental yield appreciation probability is 0.45 and with the probability that both occurring at the same time is zero point 0.3, then the probability of either appreciation or rental increased yield is equals to 0.65 plus 0.45 minus zero point 0.3, it is 0.8. This is what this rule says. Second rule is multiplication rules. P, A, R, and B. So here it was or, here it is and. it is PA into PB upon A. Or for independent events, it is PA into PB. So we will take an example that will make the things clear. For example, if the probability of a residential property value growth is 0.75 and the probability of commercial property growth is 0.60, assuming independence. So if you assume independence, then the probability of both market growing simultaneously will be 0.75 into zero point 0.6, it will be 0.45 or 45%. And third thing is conditional probability. P of A oblique B, it is PA into B divided by PB. For example, if 40% properties in a data set are commercial, so PC is equals to 0.40, and 50% of all the properties are both commercial and vacant. PC and V is equals to 0.15. Then the probability of commercial property being vacant is probability of commercial property being vacant is 0.15 divided by 0.40, it is 0.375 or 37.5%. So this is conditional probability. So there are three rules which you may have to use during your valuation process. Third, another thing which you have to know as a value is Bayes theorem in property valuation. So Bayes theorem allows values to update probability estimates based upon new information. PA oblique B is equals to PB or K multiplied by PA divided by PB. You will understand this formula with an example. Let us suppose a valuer initially estimates the 70% probability, prior probability that a property's value will fall within 90 to 100 lakh based upon commercial sales. An appraisal report, new evidence, indicated that there is 60% chance of providing this valuation range if the property truly belongs in this group, but only 20% of the chance if it did not. So using Bayes theorem, the valuer calculates the revised probability that the property's value was within this range, adjusting their level confidence level accordingly. So the probability theorem theory is particularly valuable for specialized valuation scenarios such as development land valuation, where multiple uncertain factors, planning, permission, construction cost, market absorption rates affect the final value. So probability trees and expected values calculation help to quantify these uncertainty. So as far as IBBI examination is concerned, it may include scenario requiring calculation of basic probabilities, interpretation of conditional probability in market context, or application of probability concepts to the valuation risk assessment. Understanding how probability quantifies uncertainty is essential for expressing confidence levels in the valuation report. Next thing is measure of skewness in the property market. So basically it measures the asymmetry of probability distribution, indicating whether the property values are clustered on one side with the mean side of the mean with a longer tail on the other side. So understanding skewness is crucial for property values as it reveals with the dynamics pricing anomalies and potential investment opportunities. It also affects the statistical measures which are most important for analysis. There are basically three types of skewness. One is positively skewed, then negatively skewed, and third one is symmetrically or zero skewness. Positive skewness. So positive skewness is then when most of the property clusters at lower values with few higher values, outliers pulling the mean higher than the median. For example, in neighborhood with may affordable home and a few luxury homes. Zero Skewness is when property values are evenly distributed around the mean, which equals the mean and mode in a perfectly normal distributions. For example, in a planned community with standardized housing of similar value. Third thing is type is negative or left skewness. So most properties in this case clusters at the higher value with the fewer lower values outlier pulling the mean lower than the median. For example, an upscale neighborhood with a few older, less valuable properties. So these are three types of skewness: positive, zero, and negative. So there are three methods of calculating coefficient of skewness. First one is escape one, which is called Pearson's first coefficient of skewness. For this, you have to use a formula mean minus mod divided by standard deviation. Second is Pearson's second coefficient of skewness, which is represented with the SK2. It is 3 into mean minus median divided by standard deviation. Third one is movement coefficient skewness. It is based upon third movement about the mean. Means xi minus x1 cube divided by n plus into s cube. So you have to take the sum in the numerator xi minus x1 cube and divide it with the n into x cube where xi represent each value, x1 is the mean and s is the standard deviation and n is the sample size. There are three conditions with which you can interpret the skewness. Skewness, if it is equals to 0, means perfectly symmetrical distribution. If skewness is greater than 0, it means positively skewed, right skewed distribution. And the skewness is less than 0, negatively skewed or left skewed distribution. So generally the values between minus zero point 0.5 to zero point 0.5, these indicate approximately symmetric distribution, while outside these range suggest modern to high skewness. We will take an example that will make the things clear. Consider the following rental yield percentage for 10 commercial properties: 5.2, 5.5, 5.8, 6, 6.1, 6.2, 6.4, 6.7, 7.3, and the last value is 9.8. So if you calculate mean, this means sum of these all values divided by number of values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It is 6.5%. Median is C, it is having even numbers, so you will be taking average of these two middle values 6.1 and 6.2, it is 6.15%. And standard deviation you calculate it is 1.33%. So using Pearson's second coefficient formula is 3 into mean minus median divided by standard deviations, the value comes out to be 0.79. So it is positive. So this positive indicates right skewed distribution with most properties having a lower yield but a few having high yield properties pulling the mean upward. This is visibly apparent with the last value. See here, it is 9.8 and other values are from 5.2 to 7.3. So there is a higher value on the outliers, which is increasing the mean of all the values. So this is positively skewed distribution. What are the implications of this standard central measure of skewness in property valuation? First thing is selection of central tendency measures. In skewed property markets, the median often provides a better indication of typical value than the mean, which can be influenced by outliers in the long tail. Market segmentation. So skewness may indicate distinct market segments requiring separate analysis. For example, separating luxury properties from standard homes in a positively skewed market. Investment strategies. So understanding skewness helps identify potential investment opportunities. Negatively skewed markets might offer values in the lower tail, while the positively skewed markets might offer premium opportunities in the upper tail. And then this skewness also help in selection of what valuation model. So highly skewed data may require transformation or non-parametric statistical methods that do not assume normal distribution. So as far as IBBI examination is concerned, candidates should understand how to calculate skewness, interpret its significance in property markets, and recognize how skewness affects the choice of statistical tools and valuation approaches. Recognizing skewness patterns help values avoid bias in their evaluation analysis and select the most appropriate comparable properties for accurate valuation. Next is probability distribution in property valuation. So probability distribution models it the likelihood of different outcomes in uncertain situations. In property valuation, these mathematical functions help quantify risk, predict value ranges, and support decision making. Understanding different probability distributions and their application is essential for sophisticated valuation analysis. So there are three types of probability distribution in property valuation. One is normal distribution, second one is log normal distribution, and third one is triangular distribution. So in normal distribution, the symmetrical bell-shaped curve is defined by its mean and standard deviation sigma. So mean is represented by mu and standard deviation is denoted by sigma, and the formula for normal distribution is 1 upon sigma multiplied by 2 pi square root of 2 pi multiplied by e raised to power minus 1 by 2 x minus mu divided by sigma whole square. So where this normal distribution is used, this is used for modeling property values in homogeneous market, standardized construction cost or rental yield in a stable market. Second one is log normal distributions. A right skewed distribution where the logarithmic rhythm of variable follows in normal distributions. So the formula is fx, it is 1 divided by x multiplied by sigma standard deviation multiplied by square root of 2 pi multiplied by e raised to power natural log x minus mu whole square divided by 2 sigma square. So this log normal distribution it is applied in while modeling property prices which tend to be right skewed with a lower bound at 0 and no theoretical upper limit. And third one is a triangular distribution. So a triangular distribution is defined by minimum, maximum, and the most likely values. So only there are three values: minimum, maximum, and most likely values. So it is used in evaluation when limited data is available, but expert judgment can estimate the range and the most likely values. Next is binomial and Poisson distributions. Binomial distribution. It models the number of successes in a fixed number of independent trials with the same probability of success. So Px equals to k equals to n k multiplied by p raised to power k to 1 minus p raised to power n minus k, where n is number of trials, k is number of successes, and p is probability of success in a single trial. So it is applied while modeling the number of properties meeting specific criteria in a portfolio or the number of successful transactions in a fixed number of attempts. Second is Poisson distribution. So it models a number of events occurring in a fixed interval of time. P x equals to k. Formula is lambda raised to power k into multiplied by e raised to power minus lambda divided by k factorial, where lambda is average number of events in the interval, k is the number of events, and e is the base of natural logarithm. Its value is, you know, it is 2.71828. So it is used while modeling the number of property transactions in a given time period or the number of property defects in a fixed area. We will be taking an example that will make the things clear. First, we are using for an example with using normal distribution. So a valuer need to estimate the value of a residential property in a neighborhood where the values are normally distributed with a mean of 45 lakh and a standard deviation of 5 lakh. What is the probability that a randomly selected property in this a neighborhood is valued between 40 lakh and 50 lakh? So for that we calculate Z1 will be equals to 40 minus 45 divided by standard deviation, which is 5 lakh. So its value is minus 1. Similarly, Z2 it will be 50 minus 45 divided by standard deviation 1. So the value lies between minus 1 to 1. So PZ lies between 1 to minus 1. And if you calculate its value with the calculator, the value comes out to be 0.6826. So it means there is 68.26% probability that a randomly selected property is valued between 40 lakh and 50 lakh. Second question is, if the valuer wants 95% confidence in their valuation, what range should they provide? So for 95% confidence, we need a range equals to 1.96 sigma. So you have to remember this formula. Generally, you may be asked question on this. So mu plus 1.96 sigma. Mu is 45 lakh as you have it is given in the question, and sigma is 5 lakh. You put the values multiplied by sigma is 5. The value comes out to be 35.2 to 54.8. So if you choose a range of approximately 35.2 to 45.8, so the answer will be that value will be able to get at least 95% confidence of the result. Now we will take an example using log normal distribution. So property prices in a developing area follows a log normal distribution with a parameter mu equals to 3.8 and sigma equals to zero point 0.3, where mu and sigma are the mean and standard deviation of the natural logarithmic prices in lakhs. So the median price, you know, formula median is e raised to power mu means e raised to power 3.8 means 2.718. You know the formula of the value of e. I have already discussed that the value of e is 2.718 raised to power mu is 3.8. It is given to you. If you calculate it, its value will be 44.7. Similarly, if you calculate me, the formula is mu plus sigma square divided by 2, and mu is 3.8, sigma is zero point 0.3 square by 2, the value is 46.4. So see here, in case of log normal distribution, mean is always higher than the median. Mean is 46.4 and median is 44.7. So in this case, mean will always be higher than the median, reflecting positive skewness typical property prices. So where this probability distributions are used. First thing is Monte Carlo simulation. So using probability distributions to simulate thousands of possible valuation outcomes based on uncertain inputs like future rental growth, value rates, and development cost. Second, when you need, have to confidence interval you require. So So establishing a range of values within which a true property value is likely to fall with a specific level of confidence. So you will need proper probability distribution. And, set, and next, when you have automated valuation models, you are using automated valuation models. So incorporating probability distribution to quantify the uncertainty in algorithm property valuations and generate prediction intervals. And while you have to find out portfolio risk or you have to carry out portfolio risk assessment, you need modeling the distribution of potential returns across a property portfolio to quantify the risk exposure and the diversification benefits. So, as far as the examination point of view of IBB is concerned, candidates should understand the key properties of these probability distributions, know when each is appropriate for property valuation applications, and be able to perform basic qualifications using them. The ability to interpret probability distribution results in the context of property valuation decision is particularly important. Next in is sampling methods in property valuations. So what is sampling? Sampling basically it involves selecting a subset of properties from a larger populations to make inferences about the entire market. So in property valuation, effective sampling techniques are essential when analyzing large markets, conducting research, or developing valuation models. Understanding sampling methods help values collect representative data efficiently and quantify the reliability of their conclusions. Why sampling is important in valuation? So property values are using sampling because analyzing every property in a market is often impractical or impossible. Comprehensive data collection is a time consuming and expensive. Well designed samples can provide a reliable estimate with quantifiable precision, and proper sampling technique minimizes bias and increases defensibility of the evaluations. So there are different types of sampling methods. First one is simple random sampling. In this case, each property in the population has an equal chance of selections. For example, randomly selecting 30 properties transactions from all sales in a city over the past year. Second type is stratified samplings. During the population, dividing the population in non-overlapping groups based on relative characteristics, then sampling for each strata. For example, dividing the properties by type, residential, commercial, industrial, and selecting sampling from each category. Third one is cluster sampling, dividing the population into clusters, often geographics, randomly selecting clusters and sampling all properties within these clusters. For example, randomly selecting certain neighborhoods and then analyzing all property within those neighborhoods. And next is systematic sampling. So sampling properties at regular intervals after a random start. For example, selecting every 10th property from a chronologically ordered list of transactions. That is systematic sampling. And last one is purposive sampling. So non-random selection based on specific criteria or expert judgment. For example, selecting the most comparable properties for specific valuation based upon similarity criteria. So for how this sample size is determined, the sample size is determined based upon several factors. First one is population size, which we donated n. Then is desired confidence level. So typically it is 95% or 99%. Then acceptable margin of error, we donated to E, and expected variability of probable population sigma or P. For continuous variable like property values, the formula for sample size is n equals to z square multiplied by sigma square divided by e square, where n is required sample size, z is z score for the desired confidence level, it is 1.96 or 95% confidence. Sigma is population standard deviation and E is acceptable margin of error. See here it is acceptable margin of error. It is not 2.78, it is expected or acceptable margin of error. So this is for continuous variable. If it is a finite population, then this can be adjusted by using n adjusted, it is n divided by 1 plus n minus 1 divided by capital N. So we will make the things clear with an example. For example, a valuer needs to estimate the average property value in a city with 5,000 residential properties. Previous studies suggested a standard deviation of rupees 8 lakh. The valuer wants 95% confidence with a margin of error of 2 lakh. So what should be the sample size you have to calculate? First we calculate the initial size sample. So you know the formula is n equals to z square is 1.96 with it for 95% confidence multiplied by sigma square, which is 8 lakh standard deviation divided by margin of error e square, which is 2 square. You calculate it is 61.47. So this is initial sample size. Then for the finite population, how you can adjust it? See here it is 61.47. Formula is n, and you have calculated 61.47 divided by 1 plus 61.47 minus 1 divided by 5,000, which is this number, residential property, number of residential property. So you calculate the value comes out to be 60.47. So therefore value should sample at least 61 properties to achieve this desired procedure. This is how the sample size is estimated. Then sampling error and confidence intervals. Even with the careful sampling, there will be differences between sample statistics and population parameters. Sampling error measures this difference and can be quantified using confidence intervals. For a simple mean confidence interval is x bar plus minus z multiplied by s divided by under root of n, where x bar is sample mean, z is the score for desired confidence level, s is standard deviation here, and n is sample size. So, for example, we will be taking a real world application stratified sampling in a property valuation. A valuer needs to estimate the average property values in a diverse district containing different property types using stratified sampling. These are the different property types: residential, commercial, industrial. Population size is 1200, 300, and 100. Sample size is 40, 20, and 15. Sample mean value 45 lakh, 120 lakh, and 1585 lakh for industrial property. And standard deviation is 6, 18, and 12. This is given to you. So the overall population mean can be estimated with the weighted average, means 1200 multiplied by the mean 300 multiplied by 120, 100 multiplied by 85 divided by 1200 plus 300 plus 100. So if you calculate it is 61.456. So this stratified approach provides a more accurate estimation than simple random sampling would provide as it accounts for different property types, distinct value characteristics. So while you are using this, so what are the best practices for sampling in property evaluation? First, you should have representative sampling. So ensure samples represents the relevant population in terms of key characteristics like location, size, age, and property type. And then you must have adequate sample size. Use statistical formulas to determine the appropriate sample size based upon desired precision and confidence level. And then for minimizing the selection bias, you should employ random selection methods where appropriate, and document selection criteria when using purposive sampling. So, what is a documented methodology in this case? Clearly describe the sampling procedures, selection criteria, and potential limitation and evaluation reports. Consider temporal factors. Account for seasonal variations and market cycles when sampling property transactions over time. So, as far as IBBI examination is concerned, candidates should understand this different sampling techniques, know how to calculate appropriate sample size, and be able to apply sampling principles to property evaluation scenarios. So they should also recognize potential sampling biases and how to mitigate them in practical evaluation work. Next is sampling distribution in property evaluation. A sampling distribution represents the distribution of a static like mean or proportions calculated from all possible samples of the same size from a population. Understanding sampling distributions is crucial for property values as it forms the theoretical foundations for statistical inference, allowing them to quantify the reliability of valuation estimates based upon sample data. The concept of sampling distribution is if we are to take many different random samples of the same size from a property market, we have to calculate a static exam, for example, mean property value for each sample, and plot the frequency distribution of these statistics. The resulting distribution is called sampling distribution of that static. Means uh, first you have a regional population, you draw the samples from them, you calculate the mean of these samples, and then you carry out the sampling distributions. So key properties of sampling distribution of the mean is, first one is central tendency. The mean of the sampling distribution equals to the population means mu x bar is equals to means. This means that average sample means provide unbiased estimate of population means. Then variability. The standard deviation of sampling distribution or standard error is equals to sigma x is equals to sigma divided by n square root of n, where sigma is a population standard deviation and n is the sample size. Then distribution shape. According to the central limit theory, the sample size as the sample size increases, the sampling distribution of these means approaches a normal distribution, regardless of population distribution shape. Next is central limit theory. So, what this central limit theory says, the central limit theory is particularly valuable in property valuation because property value distributions are often non-normal, typically right skewed. The CLT allows values to use normal distribution based inference even when the underlying property values are not normally distributed. It provides a theoretical basis for constructing confidence interval around the valuation estimates. For most practical purposes, the sampling distribution of Mean can be treated as approximately normal when the sample size is at least 30. Standard error. Next is standard error, means measuring the precision of sample statistics. The standard error measures the standard deviation of sampling distributions, quantifying how much samples statistically vary from sample to sample. For property values, the standard error indicates the precision of valuation estimates based on sample data. Standard error of the mean is calculated as SE x bar is equal to S divided by N under root, where S is the sample standard deviation and N is the sample size. The smaller the standard error, the more precise is the estimate. So standard error decreases as sample size increases, population variability decreases. We will taking an example that will make the things clear. A valuer collected a random sample of 36 recently sold properties in a neighborhood, finding a mean value of 52 lakhs and a standard deviation of 12 lakhs. What is the standard error of the mean for this sample? So you know the formula for standard error is S divided by N under root. S is standard deviation is 12 lakh. N number of samples are 36. Square root of 36. So 2 lakh. So this means if N many randomly sample of 36 properties was taken, the sample mean would typically differ from the true population mean by 2 lakhs. Next, calculate constructed 95% interval for the mean property value in this neighborhood. So for 95% confidence level, you know the formula is x bar plus minus 1.96 into SEX. X bar is 52 lakh. It is given to you plus minus 1.96 and SEX you have calculated 2 lakh. So it is 49 8.08 to 55.92. So we can be 95% confident that the true mean property value in this neighborhood is in between 48.08 and 55.92 lakhs. How would the precision change if the sample size was increased to 100 properties? So now the n is increased to 100, SEX is equals to 12 over 100, the value becomes 1.2 lakh. For confidence level, 95% confidence level, you know the formula is 52 plus minus 1.96 multiplied by 1.2. The value is becomes 49.65 to 44.35. So the increased sample reduces the standard error and narrow the confidence intervals, providing more precise estimate. So where this sampling distribution is used in property evaluation, first it is used for confidence intervals for valuation estimates. It provides a range of values within which the true property value is likely to fall within a specified level of confidence, acknowledging the inherent uncertainty in the valuation. Then hypothesis testing would test claims about the property market parameters such as whether the mean value is in one neighborhood differs significantly from another or whether a valuation model is producing unbiased estimate. Then sample size planning. So determining how many properties need to be analyzed to achieve a desired level of precision in valuation estimates or the market research. And for quality control in automated valuation, you have to use sampling distribution, establishing the statistical bounds for identifying potential errors or outcomes in automated valuation models. So you have to be very careful while preparing for IBBI examination. You should understand the concept of sampling distribution so that you are able to calculate and interpret standard error, construct the confidence levels, and apply this concept to a practical valuation scenario. Next is simple test of significance in property valuation. So significant Testing allows property values to move beyond descriptive statistics to make inferences and test hypotheses about the property markets. These statistical tests help values to determine whether the observed patterns represent genuine market phenomena or merely random fluctuations, supporting evidence-based valuation decisions and market analysis. The hypothesis testing framework. How it is to be carried out, now we will discuss step by step. First thing is you formulate hypothesis. State the null hypothesis H0 and alternative hypothesis H1. For example, H0 means the mean property value in the area equals the mean in B, and H1 the mean differs. First thing is we assume that means of both the areas are equal, and second, we in the both hypotheses we assume that they are not equal. Secondly, then you assume the significance level, choose an acceptable probability type 1 error, rejecting the true null hypothesis, typically 5% or alpha is equals to 0.05. Then calculate test statistics. Compute the appropriate statistics based upon sample data and hypotheses you have established or tested. Then determine the critical p-value. Find the critical value from the statistical table or calculate p-value using a software. And based upon this value, you make the decision reject H0 if the statistics exceeds the critical value or if the p-value is less than alpha. So key significant test in property evaluation. First is one simple test T. Using the compare a simple mean to a known hypothesized population, the formula is T is equal to x minus mu 0 divided by s divided by under root n, where x is sample mean, mu 0 is hypothesized population mean, s is sample standard deviation, n is sample size. So, for example, testing whether an average value of property in the neighborhood differs significantly from the citywide average of 60 lakh. Second is two sample t-test. So it is used to compare means of two independent samples, example property values in two different areas. So for this formula is t is equals to x bar minus x2 bar divided by square root of s1 square divided by n1 plus s2 square divided by n2. This is used whether the mean property values in the two neighborhoods differ significantly. And the third one is paired t-test. It is used when observation in one sample paired with observation in another test. It is based upon before and after measurements. The formula is T is equals to d bar divided by SD over square root of n, where d bar is a mean difference and st is the standard deviation of the differences. So it is applied for testing whether the property renovation significantly increase the value by comparing before and after values of the same properties. Then chi-square test for independence. It is used to determine whether there is significant association between two categorical variables. X square is equal to sigma O minus E whole square divided by E, where O is the observed frequency and E is the expected frequency. For where it is used, so it is used for testing whether the property type residential, commercial, industrial is associated with the zoning compliance issues. So we will be taking some examples that will make the things clear about these sample tests. First, we will be taking an example of one sample data. A valuer wants to determine if the properties in a new development have values different from the established area average of 45 lakh. A random sample of 25 properties in the development yield a mean value of 48.2 lakhs and standard deviation of 7.5 lakh. Step 1. we formulate hypothesis mu is equals to 45. We assume that the mean property value equals to 45, and h1 mu is not equals to 45, means the mean property value differs from 45, let us assume significant level of 0.05. So calculate the test statistics. We calculate t is equals to x bar minus mu 0 divided by s over under root of n. X bar is 48.2. It is given to you. Mean value 45 is the average value. Mu 0 divided by s 7.45 lakhs, and 25 are the number of properties. You put all the values, t value is 2.13. So determine the critical value with 24 degrees of freedom, n minus 1 and alpha 0.05 two tailed test. Critical value is, from this you can calculate the critical value by using the software, and the value comes out to be plus minus 2.064. So since the calculated value 2.13 exceeds the critical value 2.064, we reject the null hypothesis. So there is statistically significant p-value is less than 0.05. It means the mean property value in the new development differs from the established area average of 45 lakh. The sample suggests a new development has higher property values on an average. Next is two sample t-test. A valuer wants to compare the property values in the two neighborhoods. Neighborhood A sample size is 30, mean value is 62.5 and standard deviation is 8.2. And in neighborhood B, sample size is 25, mean value is 8.3 and standard deviation is 7.3. The formula for two sample t-test is xa bar minus xb bar divided by s square A divided by n, s square b divided by nb of and its whole square. You put all the values 62.5, 58.3, 8.2 divided by 30, 7.5 square divided by 25, the value comes out to be 1.9. With alpha is equals to 0.05, approximate degree of freedom is of 53, critical t value comes out to be plus minus 2.0. So since 1.98 is slightly less than 2, we would fail to reject the null hypothesis at 5% significant level, though the result is very close to the significant. And application of significance testing in property valuations. First, it is used for location analysis, testing whether the property value differs significantly between locations to identify premium areas, and spot location adjustment in comparable sales analysis. Next is market trend analysis. We may use for testing whether the observed changes in the property values over time represent statistically trends, significant trends rather than random fluctuations. And property future impact, testing whether the subject property features, means pool, extra bedroom, garage, have a significant on the property value to support or refute adjustment factors. And for valuation model validations, testing whether the valuation model estimates differ significantly from the actual sale prices to assess model accuracy and potential bias. So for example, for IBB examination, you candidates must understand the principles of hypothesis testing. Next is regression analysis in property valuation. Regression analysis is a powerful statistical method that examines the relationship between a dependent variable, typically property value, and one or more independent variables such as size, location, age, etc. The technique allows values to quantify how different factors influence property values, create predictive models, and make evidence-based adjustment when comparing property. First one is simple linear regression. The simple linear regression examines the relationship between the property values and a single independent variable, modeling this relationship as a straight line. Y is equals to beta 0 plus beta 1 into x plus epsilon, where y is equals to dependent variable, typically it is property value. X is independent variable, it may be property size. Beta 1 is y-intercept when x is equals to 0. Beta, beta 0. And beta 1 is slope coefficient when the change in y for 1 unit change in x. And epsilon is error term unexplained variation. The regression equation is estimated using the method of least squares, which minimizes the sum of standard differences between observed and predicted values. For that, you have to calculate beta 1 is equal to xi minus x bar multiplied by yi minus y bar, summation of all these values divided by xi minus x bar whole square, sum of these values. And beta 0 is equal to y bar minus beta x into x bar. So we will be taking an example that will make the things clear of simple linear regression. A value collected the data of 8 recently sold properties to analyze the relationship between built-up area x in square feet and the sale price y in rupees. So these are the data which he has collected. So x bar you calculate the value. Sum of this values mean comes out to be 1206.25. Mean of y it comes out to be 58.75. Through calculation beta is equals to 0.05, meaning each additional square root adds 0.05 for 40 lakh or 4,500 to the property value. So you put the values, beta 0 is equals to 58.75 minus 0.045 multiplied by 1.206.25, 4.47 lakh. So you have calculated the value of beta 0 and calculated the value of beta 1. You put all the values here. Y is equals to 4.47 plus 0.045 multiplied by x. So by using this equation, you can estimate the property value of a 1350 square feet. You put the value of x is equals to 1.1350. Your value comes out to be 65.22 lakh. Next is application of regression analysis in property valuation. First, it is used for mass appraisal. So, developing statistical models to value large number of properties efficiently for taxation or portfolio valuation. Then you can use it for adjustment quantifications, determining the objective adjustment factors for differences between subjective and comparable properties. Then we can use it for market analysis, quantifying how various factors influence property values in specific markets to support market trend analysis. And then it may be used for valuation verifications, testing the reasonableness of the valuation by comparing them with the regressional based estimates. Then it may be used for development feasibility, modeling how specific development features adjust the potential property value to optimize project design. So limitations and considerations of this regression analysis. So it depends upon the data quality. Regression results are only as good as the data they are based on. Then model specifications, including irrelevant variables or omitting important ones can be biased result. Then linearity assumptions. Standard regression use linear relationship which may not always be hold good. Then multi-collinearity. High correlation between independent variables can make efficient estimate unstable. Then market segmentation. Different properties of markets may require separate regression models. For IBBI examination, candidates should understand the regression concepts and be able to interpret regression equations and statistics. Know how to apply regression in property valuation context and recognize both strengths and limitation of regression analysis. Next is correlation analysis in property valuation. Correlation analysis measures the strength and direction of a relationship between variables without implying causation. In property valuation, correlation analysis helps to identify factors that influence property values. Quantifying these relationships and support valuation decisions with statistical evidence. Understanding correlation is fundamental for developing reliable valuation models and making market-based adjustment. Basic concepts of correlation. If the variables moves in perfect tandem in same direction, so we say correlation is positive one. As one increases, the other one also increases proportionately. If it no linear relationship exists between if it exists between two variables, then the correlation will be zero. Means changes in one variable have no consistent relationship with the changes in the other. And minus one, it means variable moves in perfect opposite direction. As one increases, the other one decreases proportionately, and vice versa. So in practice, most correlations in property valuations falls between the extremes with the values plus one or minus one indicating their strong relationship. So we should know the Pearson correlation coefficient. This is the formula for Pearson correlation coefficient, where x and y are the individual observations and x bar and y bar are the mean variables. We will make the things clear with an example. We have evaluator has collected the 8 properties, data of 8 properties and analyzed the correlation between different factors of the property values. We have taken size, distance from the central business district, age of the building in years and values. We collected the data of the 8 properties like this, and we by using the software you can calculate the correlation between these size, distance from the central business distance and age in years, and you can try graph to represent the values. So size and value, strong positive relation correlation 0.93 indicates larger properties tend to have higher values. Distance and values, strong negative correlation minus 0.86 indicates property farther from the central board. Business distance tend to higher have lower value. Age and value. Neg- strong negative coefficient indicates properties tend to have lower values. See here. Testing the significance of correlation. To determine whether an observed correlation is statistically significant, we can perform a t-test. This is the formula for that. For example, with size and value, let us suppose r is equals to 0.93 and n is equals to 8. You put all the value, it comes out to be 6.20. With 6 degrees of freedom, n minus 2 and 2 tail test at 0.05, the critical t value is plus minus 2.45. Since our value is 6.20, it exceeds the critical value. We conclude the correlation between size and value is statistically significant. Next is coefficient of determination. The coefficient of determination R square, it represents the proportion of variation in one variable that can be explained by the other variable. It ranges from 0 to 1 and is calculating by squaring the correlation coefficient. In our example, size and value R square is equals to 0.96 square means 0.8649, meaning approximately 86.5% of the variation in the property value can be explained by the property size. Distance and value. R square is equals to 0.86 square is equals to 0.7396, meaning approximately 74% variation in the property values can be explained by distance from the central business district. Agent value R square is equals to 0.91 square means 0.8281, meaning approximately 82.8% of the variation in the property values can be explained by the property size. Next is rank correlation. When data does not follow a normal distribution, a relationship is not linear. Sperman's rank correlation coefficient RS provides an alternative measure. It assesses how well the relationship between two variables can be described by a monolithic function even if it is not linear. So its formula is Rs is equals to 1 minus 6 sigma d I square divided by n into n square minus 1, where di is the difference between the ranks of the corresponding observations and n is the sample test size. Next is multiple correlation. Multiple correlation coefficient R means a combined relationship between multiple independent variables and dependent variables. It is calculated from a multiple regression model ranges from 0 to 1. A scaled multiple correlation R square represents a proportion of variation in the dependent variable explained by independent variables combined. Where this correlation analysis is used? It is used for identifying which property characteristics have strongest correlationship with the value, which helps the value to select most relevant comparable properties and property prioritize adjustment. Then for adjustment quantifications, correlation coefficients help quantify how changes in one property characteristics relate to the changes in the value, supporting the evidence-based adjustment. Then model development. So correlation helps analysis help in identify which variable to include in valuation models and assess potential multi-collinearity issues. And for market analysis, we may use analyzing correlations between economic indicators and property values, help values understand the market drivers and forecast trends. So limitation of correlation analysis. First is correlation versus causation. A strong correlation does not necessarily imply causation. Other factors might be responsible for observed relationship. Non-linear relationship. Pearson's correlation only measures linear relationship. So property variables may have some low non-linear relationship with the value. Ecological facility. Correlation between observed at one level, that is neighborhood, may not be applied at the another level, individual property. And outliers. Extreme values can significantly distort relationship coefficient, potentially leading to misleading conclusions. So for IBBI examinations, you should understand how to calculate and interpret correlation coefficient, test their significance, and apply correlation analysis to the property valuation scenario. So this is all for statistic use of statistics in valuation of real estate. Thank you. Have a